Learn with Peppa Pig.
Reaction force. It is a school day for Peppa and her friends. Does anybody know what reaction force is for?
Let's try to solve this. These supports are taking the upcoming load in an upward direction. Thus, this will be our first reaction and will be labeled as AY. This is our second reaction or the BY. These are the required or unknown reactions. Now, let's start with this reaction A, which is the acting output direction and will create movement in the clockwise direction about point B. The AY or the reaction A multiplied to the total distance between point A and point B, which is 10. The momentum has clockwise movement, so it will be taken positive due to the clockwise moment are taken positive. Next, the 5 kN creates a movement about point B once more. But this time, the movement will be created in a counterclockwise direction, going downward to the point B, so it will be taken in negative. So it will be minus 5 multiplying with the total distance of between the 5 kN pointed load to the point B, which is 7. Now, since the distributed load also creates movement around point B, we must first convert it to a pointed load. Since this 2 kN acts over the distance of the meter, the result will be 2 multiplied by 4, which equals 8. Since it also creates movement counterclockwise, the result will be negative, or minus 8 multiplied by the force X at the center, or 4 meters, divided by 2, which equals 2 meters. Again, let's compute it in calculator. So AY multiplied by 10 minus 5 multiplied by 7 minus 8 multiplied by 2 is equal 0. The answer that I get is 5.1 kN. Reaction A is equals to 5.1 kN. We finished solving the reaction A. Now let's go to solving the reaction B. Now, how to find out the reaction B or BY? So we will take help from this equation. The summation of all the vertical forces is equal to 0. So reaction A and reaction B are both acting in upward direction. So it will be taken as positive, while the pointed loads are pointing downwards, so it will be negative. So reaction A plus reaction B minus 5 kN minus 2 kN distributed by the loads, so multiply by 4 meters. Substitute the value of reaction A, which is 5.1 kN, and change sign. So it will be reaction B or BY is equals 5 plus 8 minus 5.1, which is the value of reaction A, and the answer will be 7.9 kN.
Who can give a sample problem and solution for reaction?
Me! Okay, Pedro.
My example is this beam. It is an 8-meter simply supported beam with a left pin support and a roller at the other end. It also has a 50 kN moment 2 meters away from the left pin support, a 30 kN point load at the middle, and a 10 kN distributed load spanning 2 meters from the roller support. We can solve the reactions for each support by doing as follows. To get the reaction at the left support, we have to do the summation of the moment positive with respect to E, which is at the roller on the right. First, we have the vertical force AY multiplied by 8, which is its distance from the right support, followed by positive 50 because the direction is clockwise. No need to multiply the distance for this instance because it is already a moment. Next is negative 30 because the direction it takes is counterclockwise, multiplied by its distance, which is 4. And finally, we have a 10 kN distributed load. To get its total force, we have to multiply it first with the length the force covers, which in this case is 2 meters. 10 times 2 is 20. The sign is negative because it turns counterclockwise, multiplied by the distance of 1 meter from the right support.
Rebecca.
Always remember that in case of distributed loads, we use the center of the length as the starting point for the distance of the force from the support where we are doing the moment.
Now, we can transpose all the other terms aside from AY and divide both sides by 8 in order to isolate it. From there, we can get 11.25 kilonewtons. Just to sum it up, we have the negative EY because the direction is counterclockwise, positive 20 multiplied by 7 meters distance, positive 30 multiplied by 4, and positive 50, which is a moment. Transpose EY to make it positive, divide both sides by 8 to isolate it, and that's how we get 38.75 kilonewtons. You might also notice that the total upward forces are equal to the total downward forces. This is because the beam is resisting the downward loads by exerting upward forces, following Newton's third law of interaction, stating that for every action, there is an equal and opposite reaction. Did you get it?
Yes, reaction force is the force applied to a structure when it rests against something. In analyzing a beam structure, it involves calculating what the reaction forces are at the supports due to the forces acting on the beam. A free body diagram of the entire beam can be used to determine the reaction forces. The beam has vertical and horizontal reaction forces as well as a reaction moment. The horizontal reaction force is 0 as long as there are no horizontal applied forces. A cantilever beam with a single support has a reaction force and a reaction moment. The reaction force equals the sum of the applied forces on the beam. If the beam sits on a roller that allows the beam to move freely horizontally, its support has only a vertical reaction force. When put under compression or any type of stress, every material suffers some deformation, even if that causes the average relative positions of its atoms and molecules to change. The deformation may be permanent or may be reversed when the compression forces disappear. In the latter case, the deformation gives rise to reaction forces that oppose the compression forces and may eventually balance them. Liquids and gases cannot bear steady unaxial or biaxial compression. They deform promptly and permanently and do not offer any permanent reaction force.